Good morning, good afternoon, good evening, and welcome to a very special episode of GitOps Guide to the Galaxy. I am joined by two of my fellow Red Hatters, Christian Hernandez and new to the show, Michael Foster. Christian, how's your day going? How's your pre-KubeCon week?
It's been crazy. It's been what we call a sprint to KubeCon, right?
Yes.
Because all of a sudden, wow, KubeCon's next week. Whoa, okay. I better get to my demos. So
I'm flying out on Saturday.
There you go.
Yeah.
Fun times.
Speaking of
enjoy the traffic, right?
There was a note that Stu sent to you yesterday that you need to answer in Slack.
Okay. Yeah. I actually thank you for that. Thank you for following up live. So
yes.
Also, real quick, and I'd like to introduce Michael Foster here in a second. I'll let him introduce himself. I actually got a new keyboard. There was a saga of me getting my new keyboard.
It took him 8 months, folks.
It took me 8 months
to get a keyboard.
Yeah, so supply chain issues. But anyway, so if you hear loud clicking, that's my new Cherry MX Blues. So I want my neighbors to hear when I type. So anyway, that aside, I like to this is a very long intro. I'd like to introduce Michael Foster from the ACS team. Michael, if you want to give a brief introduction. He's from the ACS team, former minor league baseball player, all kinds of crazy stuff.
Going way back.
Yeah, going way back.
Way back.
So, anyways, Michael, give a little short intro about yourself.
Yeah, thanks for the intro. Hey everyone, I'm Mike Foster on the ACS team, formerly Stack Rocks. We came over April, I think, was the official date that we moved over. So it's been a fun 6 months so far. And thanks for getting me on the show. Been around Kubernetes for 4-ish years now. And yeah, I have a diverse background. Used to play baseball and I went to school in Northeastern Boston. So yeah, thanks for having me.
Yeah, no, it's
great to have you.
Yeah, it's great. I was going through this. It's actually been a while. I invited him on the show, but since we had so many, we did a show plan and we had so many shows that it's like, okay, well, you can come in October. This was back, closer to the acquisition than anything else. I was trying to get the guys from Stack Rocks on, but very happy to be here. A lot of the times when I talk about GitOps and when I talk about the GitOps practice, I always talk about it being the core of a lot of other practices. For example, the latest buzzword is like DevSecOps, right? And like application supply chain delivery, and how GitOps really has to sit at the core of that, right? Like GitOps isn't the complete story, but it's part of that story. And I've been wanting to bring in the Stack Rocks over and kind of just explain kind of a little bit about that whole vision of having security be part of the process, not just like an afterthought, and then continuously monitoring your process even after you've deployed your application, and that being part of the whole speaking of supply chain, right? We're talking about the application supply chain. So yeah, I'm gonna shut up for a little bit. Let Mike over here take over a little bit. Talk about ACS, right? Talk about Stack Rocks. Talk about ACS. Talk about that whole ecosystem.
Yeah, you nailed it. Especially the DevSecOps word, that buzzword that you keep hearing. It's about breaking that down because it's so high level. Nobody really knows how to actually apply that. And so, just want to show you some practical examples. Hopefully, you can apply it to your use cases. And when I share my screen, I'm going to take you through just a couple slides. I won't bore you. Everything showing up okay, right? Everything's clear?
Looks good to me.
Awesome.
Looking good, Chris? No? You're on mute, by the
way. You're muted.
You're muted.
It's all good.
Okay.
Awesome. Yeah, so the vision of Stack Rocks and ACS now is to enable organizations securely build, deploy, and run cloud-native applications everywhere. And earlier in 2017, Stack Rocks was a more container-focused security service, and you'll hear cloud platforms and container-focused platforms that are out there. But we really pivoted to Kubernetes, and it's because Kubernetes has a specific challenge that it presents to developers and operation teams that is slightly different from, let's say, a serverless process. There are a whole array of configurations with Kubernetes that are challenges. And if you want to deploy at the speed at which the developers can introduce functionality into your applications, you need a security process that can keep up with that. So it's about securing the supply chain, securing the infrastructure, and making sure that your workloads, that process fits in with the developers and the containerization techniques that you have so that you can securely scale. And I'm not going to go too much into these slides, but it's just about delivering continuous security and fitting into the process that you have, right? Because if you've adopted Kubernetes in any sense, taking a security solution like ACS, you might be, hey, like, how are we going to implement this? So we'll show you. And really, it's about just full lifecycle security of the things that you have to take care of, which cloud platforms kind of leave up to you. And in a shared responsibility model, you'll see on the different providers that are out there.
Yeah, one of the things, and to kind of just frame this a little bit, I liked Eric Jacobs. I don't know if it was Eric Jacobs or if it was you who talked about kind of comparing, when you say application supply chain, that it's really nice to have an analogy, right? And that's like the analogy of, like, you're talking about the assembly line, how there's no like dev assembly line, right? Like like if you think about like Henry Ford and like building a car, the assembly line, they don't, there's no like dev version of that somewhere. Maybe R&D is the dev version, who knows? But like, like there is no dev QA, like all that happens in that same supply chain, right? So in that same, it's all that same process. Like, it shouldn't have to be an afterthought. It shouldn't have to be something you do on the side, right? It needs to be all inclusive. So
yeah, and I almost see the security solutions, especially Kubernetes native ones like ACS, as the quality control for that supply chain. So your developers have already have an application, or they have something containerized. So they have their V1, 0.0, whatever you want to call it. And now it's just about, let's rein in some things and let's enforce it upstream so that all your parts are, up to size and have the right capabilities and everything is okay, so that your final product is stable and secure and won't wear down, let's say. That's if we're going to go with that analogy. But just to talk a little bit about ACS as I transition, is when we talk about Kubernetes native, it's the architecture. If you're used to something like a Fluentd, or logging controller, right? You're going to have one central UI, and that's the UI that I'll show you in a bit. And it has basically all the data analysis, the scanning components, and it's just pulling information from your various clusters. So you can have multi-hybrid setup on different Kubernetes clusters, and you can pull all that information into a single UI. One of the benefits of this is you can easily onboard clusters and push policies that you already have in your UI into new clusters and new applications as well. And then just in terms of the layers for Red Hat, you'll see that advanced security and management are sort of that top layer that you'll see, because like a lot of platforms really kind of only give you the Kubernetes specific part of that, right? And so how do you grow and scale your cluster, and then how do you secure your own applications? That's something that a lot of you're going to normally need to go to an extra service unless you have bought into the specific cloud provider. But that's enough slides. I think we can jump into the demo.
We like hacking at it until it works.
Yeah. We'll get there.
Yeah.
Let me just move over and share a new screen with you. There we go. Everything's good?
Now it is. Yeah, now it is. Ultra-wide monitor rocking, dude.
Yeah. Is it a little?
Man,
is it a little?
It's very tiny.
Stretched.
Yeah.
Okay.
Well, you can if you can zoom in with Control Shift.
That I can do.
Yeah. Thank you.
There we go.
It work?
Yep.
Cool.
That, what is that, like 300%? What did you?
Yeah. What is it?
Right. Like, what is your zoom level?
250. There you go.
Okay.
I think that's a new record, right, for this show.
I think so. Yeah.
Nice.
Mm-hmm. All right. Yeah. So to start off, I have an OpenShift cluster set up. This is fairly recent. I think I set this up a week ago. And
yeah.
Nice, good reference. And installed some demo applications and installed a couple operators. ACS can be installed as an operator in your cluster. And I think I have 4 here. So we have Quay, we have OpenShift pipelines, we have GitOps, and we have ACS in the cluster. It pretty much is as simple as coming in, enabling OpenShift cluster or advanced cluster security for Kubernetes, picking the specific namespace that you want. I called it StackRox because you got to keep the name alive somehow.
That's right. You gotta you gotta keep that flag going. Yeah.
Yeah. And once you get in here, you'll see that part of the differentiation of the architecture that I showed you is there's a central component, which is the UI and all the tools for analyzing all the information. And then there's the secured cluster component. So the central cluster component is the one that you're going to want to install first. It's deployed initialized. It'll give you the UI that you can go into, and then you can bring on clusters as you go. And you can do this in an automated way by basically generating the certificates. And then as clusters come online, they'll automatically get populated, and they'll reach out to the UI to say, hey, I'm here. Or you can do it manually just so that you don't have that automation aspect of something reaching out to your UI, but you have that capability. So I'll just go right into it. Have a couple applications installed on here. I think I was actually given some pretty insecure ones, and I haven't seen them yet, so interested to see what pops up. Now, this is just the main dashboard, which I should probably zoom in on again to 200% so everybody could see. And we only have one cluster. If you had multiple clusters, obviously this would show up here. You'll see system violations, compliance standards. It's your clusters at a glance dashboard. And just
to see that we don't have any critical.
Yeah.
I'm actually very surprised. Yeah. Yeah. So if we wanted to, what do we want to jump into first? Let's jump into violations because it tends to be.
By the way, sorry to interrupt, but so by the way, I told Michael, if you go back to violations, that first violation is probably like the thing that sold me on ACS, the StackRox, is like, hey, someone accessed the kube admin secret. Oh. And it knows that the ACS knows that, and
right.
Like this is something I wish I had like an OpenShift version 3.
Right.
Because you're right, like which goes to show you how Kubernetes, the whole ecosystem has evolved. Like now we can do things like this. It's like, oh man, things as common as someone accessing something, getting an alert now seems like, oh, that's really cool. You would think that would seem like intuitive that you would have in the platform, but
sure. Maybe not.
But well, I mean, Kubernetes was so young back then, right? It's like now we're at that point. So, anyways, like I was kind of joking with Mike here about like you basically sold me like you sold me on StackRox just with that one line of the violation. But anyways, sorry, I didn't mean to derail you, Mike, but I just thought it was a really cool thing to see.
Yeah, that's it. There's like kubeexec really commands that show that either somebody's in production or somebody's in your developer, like trying to access secrets or trying to get into a container. Those are things you want to alert on, which is why the severity is high. And obviously it's not enforced right now. So by default, ACS doesn't enforce anything because you have to go and install an admission controller to do that. And there is security aspects of doing that as well, right? It's actually part of the MITRE ATT&CK framework of exploiting admission controllers, specifically mutating ones, right? So it's your choice whether you want to do that, and then how you're going to enforce it. You need to make sure that you are aware of that as well. So just by default, it's, hey, come in, take a look around, understand where your high-risk deployments are, and go from there.
Yeah, a lot of security is just, first of all, just information, right? Like just what's going on in my cluster.
Yeah, that's exactly it. And the challenge and really the pitch is that you don't want security chasing things that it doesn't need to worry about, right? You want to be able to identify the things that actually matter to you and that you can take action on. So you're not just pushing things onto other teams that has no impact, right? Or doesn't protect anything. But real quick before, I want to show vulnerability management because it's one of my favorite sections. ACS has a bunch of default policies set in that take your information and apply Kubernetes best practice to them. Now, for example, that kubeexec one, or the, where'd it go? I forget. But let's say there's specific categories or a specific policy It doesn't have to be high. So you can create and edit things if you, let's say you disagree with the severity of something, or it's a dev cluster and you don't really care that much. All these policies can be changed and configured accordingly. So it's we can have comments. So if a violation pops up and it's something that's continuously there, you can leave comments for the next person to come in, and you can export all these policies as well.
That's pretty cool. So you can say like, hey, this was me. Right? Like, oh, hey, it was me. I accessed this. That's actually how you wouldn't think, like, that's actually really smart. Like, because I would have never thought to put like that in, like if I was like designing this. But like as an afterthought, I'm like, oh yeah, like that would be cool to put like just some information for someone else that's taking a look at the violation.
Mm-hmm. Yeah, and a lot of this tool is about baselining. When we get to the network graph, you'll see it as well. You have to accept an inherent amount of risk, and that's why risk is such a cliche thing to say in security, right? And just risk in general to define. So it's here's the information, here's the best practice, the things that you need to worry about, and then it's up to your security team as to how you want to enforce it. We're not going to. Some security tools tend to be very opinionated about what you're supposed to enforce, and that can lead to like false positives or breaking builds that you don't necessarily want to. So we tend to err on the Kubernetes approach to, hey, come into the cluster, everything's pretty much wide open, and then you can go from there and really secure, right? Because if we had network policies enforced by default in Kubernetes, I'm pretty sure it would not have got adopted right away.
Yeah, exactly.
Right,
No one would have used it. Well,
Exactly.
and also kind of like one of the things about security, and especially like vulnerabilities, especially for the information, is like, well, not everything like requires action, right? Like it's a little
Right.
difficult to explain where it's like, hey, I scanned the Red Hat official image and all these severities came out. I was like, well, like, did you actually read the CVEs? Like some of them,
Yeah.
like it
It's
may
like
be just
you have to
information.
do
to you.
something to invoke it, right? Like
Yeah,
sometimes,
exactly.
right?
Or like maybe it's mitigated, or like maybe it's
yeah,
just
it could be
information. Maybe
handled
it's
at a higher level. Anything is
who
possible.
knows?
Yeah.
Mm-hmm. And a lot of, I don't want to, let's just say that certain tools and certain providers and things like that, it's just, here's the CVE, you need to be aware of it. But then if you're using RHEL or something like that, it should be, okay, we really don't need to let you know about every single CVE that's out there. It's these are specific to you. These are the things that really matter. Or, I mean, even if you have vulnerabilities in your images, it doesn't necessarily mean that they're exploitable or really active at any aspect in your container being used. So there's things that you can do to basically say, hey, these are the fixable aspects. Like these are some things that you can't fix, but do you really need them in the container? Are there other options? So yeah, it's just about triaging accordingly, right?
So we got a question in chat here, guys.
Shoot.
Is the ACS operator supported for disconnected clusters?
I believe so.
Yeah, so
I can. Yeah,
you kind of have to ferry all the container images and everything into your environment, but after that, yes, in theory, it should be supportable for disconnected.
Yeah, and you'll set up a mirror repository or something like that to pull the vulnerabilities in every month or so. But yes, that's a good question. And StackRox has pretty much always supported that from the beginning. I guess at that point it'll be just more manual, right? Like right now, StackRox will be, or ACS, I better use the product name, is reaching out and pulling that information. I would imagine in disconnected, you would have to sync that yourself.
Yeah, you got to ferry the info data, and as well as the images.
Mm-hmm.
Got to sneaker net it in on your little floppies.
Yeah, so I will say one of the riskiest images that we have here are the workshop, some of the demo applications that we've set up.
Yeah.
Right.
And it's always funny because riskiest is very it just depends, right?
Yeah. Well, what's funny is like it's relative to your cluster, right? Like if you have like if everything's perfect and you have one medium, right, that one is technically the riskiest, right? Mm-hmm. There's actually a question in the chat, and I think you're going to get this to a little later, but I'll ask this now. Feel free to punt it down. It says who resolves the CVEs?
Good point.
That's a great question. So you've identified a CVE. If there is, maybe it just needs an upgrade. So maybe you push to your devs and you say, hey, build this pipeline right now. Or maybe you understand that you need to change versions or something like that if there's a quick fix. Normally when CVEs are released, they tend to come with a fix associated with them by the application developers if something's major. Most likely that will, so if a new CVE comes out and it's something that's high level, you'll get an alert that, hey, this is something that can be fixed and is relatively new. It just needs an update. That's one example. Another one would be, there could be a vulnerability that doesn't necessarily, it might be rated as low, or you need a specific exploit, like you need, let's say you need to have access to port 80 or something like that. Well,
Python 378 with port 80 open, you're screwed. Yeah.
But, but realistically, if you have the configuration file in your deployment set up properly and your network policy set up so that that port can't be accessed, it's not really an issue, right? So there's more to just, hey, I have a vulnerability, I need to push it so that we can make the change at the build stage. You might not need to. And that you might want to get to that eventually, but that's not high priority for the team, right? So there's more context that needs to be added to.
Yeah, because this here, like this one here, like I'm looking, this looks like this image here. By the way, it's my image, I know. I'll admit it. This is one of my test images. But Michael's like, well, do you have some test images? Oh, like, I have some images that'll light up like a Christmas tree. But it looks like some of these, it looks like I just need to rebuild the container, right? Like I just do a yum update in the container. Looks like specific to this one, right? Like this one's Apache.
Yeah. So have been updated with the new collections. So you need to do an update basically. And then if you want the full CV description to understand a little bit more, you can go there as well. And really that's, if you're going to go to the overview, if I were to go back to the main screen, if we view all and we sort by fixable, like these are the ones that we want to focus on, especially the recently detected ones. So the biggest thing about ACS is the longer it runs, the more you get a baseline for what your services should be, network, images that are running, users, and you'll start to see, okay, there's a change, there's a new CVE from the newest update. It's a fixable one. This is probably something that's recently come out that just needs an update or a patch to do. Let's prioritize that, right?
Do that. So someone asked in the chat, the StackRox has its own dashboard UI like OpenShift or Satellite. Yes, this you're actually looking at it. It's just it looks a lot like the OpenShift one.
Top left. Yeah. We use a common kind of framework called Patternfly here at Red Hat. So like our applications kind of look consistent as a result. But the logo in the top left is the dead giveaway.
Yeah. So the answer to that is yes.
I believe you can put your own logo up there if you're feeling if you want to differentiate.
You totally can.
Yeah. There was this competition.
We did a console customization competition last year.
Yeah, console customization. Yeah, we did. That was it last year. All my years are
like it's like go back and look it up, folks. I'll find the link and drop it in chat. But it like some people did some really cool stuff with their consoles.
Yeah.
So and there's links to like the repos and everything. I'll go find it.
Sweet. And then, well, since we were talking about fixable CVEs, I figured I'd show you this dashboard. We can look specifically, we can sort by fixable. We can also snooze ones. So let's say as your security team, you've installed things and obviously there's a ton of containers running. Really what you want to focus on are things with a high CVSS score, things that have high impact that can be exploited. And also we want to look at the amount of components and deployments that are associated with it, right? Is this something, the more prolific this is, maybe it's a part of a base image that you constantly use in a lot of your applications, that would have a big impact to fix, right? That's something that it's like, hey, everybody team wide, we need to just go and upgrade this specific part, or we need to pull a different base image to make sure that this is changed, and that will have a significant impact. So this extra information helps you triage.
Yeah, you can also I think mitigate that with like UBI, right? Like if you're using Red Hat UBI, and like your cluster's like, whoa, you're vulnerable, but like if all your images are based on UBI, you can probably just update your base image at one place, right? And it should cascade, right? Across your environment.
Definitely. I don't think I've actually done this yet, but
Let's scan it. Let's do it.
Yeah, configuration management. this is the other aspect. And this is when we talk about risk in this dashboard, we're pairing vulnerability management and the images themselves with the configuration of your application in the cluster. So there are other things that and policies that violate basically best practice here. So curl in an image, right? Being able to pull, if you don't need curl in the image, don't have it there. Using add in your images, secrets mounted as environment variables. That's one we see pretty often. Old images. So this is pretty common, right? I think Christian, your image probably failed that one.
Yeah. Yeah, all of these are probably mine. Yeah.
Yeah, so you can see the policies that are being failed, and this is cluster wide. So maybe you make an exception for specific ones, but in general, this is a policy that you want to have. And of course, you can change the format. You can make it 120 days. You can make it 60. You can make it 2 if you wanted to. And just there are also little things, like required labels and owners, right? So you can enforce best practice, and this can be done earlier in the pipeline too, if that's something that you're interested in. But it all culminates with basically a risk assessment that's highlighting the riskiest deployments, and it's giving you a priority score of what you need to focus on. So we have some very severe violations, environment variables containing secrets, and some fixable severity, some fixable vulnerabilities that you need to get to.
You're pulling the curtain here on my image.
Yeah.
More like pulling the rug out from under it.
Yeah, exactly.
And as we go down to, there's a little bit about the service configuration. So no capabilities were dropped. So assuming that there's no security context on this deployment, which means it has full capabilities, not great. Volumes are mounted with read-write, ports exposed, components that are useful for attackers. So this image contains bash, curl, RPM, and yum, and has no components dropped. That's that's something that you want to fix pretty much as soon as you can. Number of components in the image. Yeah, so this is obviously a larger image. There's 227 components. So basically we scan the Docker file and you get a list of all the components to go and take a look at. And then you obviously have the default service account as well. So this is probably one of the riskiest things you could ever do in the cluster.
Yeah, so there you go.
And look at this. This image is over, 3 years old, 4 years old?
It's about 3 years old. Yeah, that's about right.
Oh, yeah.
So
everyone look away.
Christian, I'm not calling your baby ugly, but your baby's ugly.
It's a really ugly baby. Oh, and also I'm using MySQL. I should probably switch to MariaDB. There's just all kinds of stuff wrong with this.
Yeah, like the list never ends.
It's never ending.
But if there was a security context, it would be here. There isn't. Although you do have the resources set up.
There you go. That's one. There you go. I got
half a star out of 5.
Half a star out of 5. Exactly. Star. That's exactly half a star out of 5.
0.5. You got a 5. It's just where the decimal point.
The decimal point moved over 1.
Now, the nice thing is on the event timeline, you have no policy violations of actual running processes. So even though you have a specific process they're running, you haven't violated anything. But if we were to view the graph, we can see when specific processes were run in the event time. And what's useful about this is you can set up alerts. So I could set up alert on something that is a quote unquote risky deployment to say if bin/sh gets run, alert me, send me a notifier. So what you could do is, let's say you know that you can't harden your image in time, or your dev team says, hey, we're going to get to this, but it's going to take a day. Okay, well, I'll set up a notification on this image for the next day so that if anything happens in the day, I get alerted right away and I can go and destroy that pod.
Yeah, that's pretty cool. So that way you'll have sort of like, all right, well, in case something happens while they're fixing it, I can be notified, right? I can send it to PagerDuty or a webhook or whatever, right?
Yep. And because we use the admission web controller for enforcement, let's say there was a process that you didn't want to run and you wanted to stop that process. Well, all we do is we just kill the pod, because unless you want to kill the deployment, you kill the pod of that process. The service is still up and it just goes and brings up another one. So something as simple as that, if an attacker was able to get access to the pod, they'd only be able to run one command, they get kicked out right away. And then they can try again, and they're going to keep getting kicked out, but then you're going to get notified and you're going to make an adjustment. And it just allows you another sort of layer to respond without having to shut everything down. It's an option. Some people would just say, hey.
Just pull the Ethernet cable off the wall. Well, what I find surprising is that I actually pulled an image. So like I pulled an image from Docker Hub that I know that was pretty old, and yet my image was still the highest.
Somebody has better standards.
That's right. Well, they probably have a build pipeline, right? Like,
exactly. You probably just were like, "Hey, what's vulnerable? Put it all in here."
Yeah. Does Nginx even appear? Does Nginx even appear on this list? I don't know.
I don't think so.
Yes, not even there.
I don't know, but
there you go.
I do want to show the network graph and a little bit of the pipeline I set up before we get caught up on time. So yeah, this is the network graph. It would look a lot cooler if I had a load to run against this cluster, but since it's pretty new, we don't have a lot of connection information. Typically, you have this active and allowed view, so you can do both. So connections that are allowed and active, ones that are currently being in use. The blue sort of signifies that a network policy has been set up. Red means it hasn't. So these are ones that you definitely want to go to and say, hey, there's an anomalous flow, and we need to make sure that network policies are set up for these. Right now, there isn't. And there are a bunch of updates available too. So this is definitely a cluster that needs some work. And one of the best things about this, honestly, is the baseline. So this is baseline traffic. Wait, let me go back here. Yeah. So for the scanner database, there's two baseline flows. It's basically scanner. This is expected, right? Ingress in the namespace StackRox. What's not expected to the UI is all of the network flows in the cluster. So this is something that's picking up. It's saying, hey, these are open connections. These are something that we're not expecting. Now we can add this to baseline, or we can basically generate a network policy to account for that. So you can simulate a network policy and account for the network changes, and it will recommend an option. Now, there hasn't been really any traffic in this cluster, so the network policy isn't really going to be accurate. So it thinks that there's a lot of connections, and that's what you want. But the other thing too is if you set up your baseline and you say, hey, these are the 3 connections that are part of the baseline, anything that breaks that, you can alert on.
Nice.
So this is really useful, especially for, and you don't want to alert on everything, right? But let's say you have databases or, sectioned off nodes that are for specific workloads. Those will show up in your network graph, and then you can click on that and say anything to and from these specific pods, these specific deployment resources, I want to be notified if it violates the network baseline.
That's pretty cool. So it not only will it notify also? See, now I'm starting to sound like a customer. Will it notify also if if I have a network policy set up, right, and it'll block traffic? Can I get alerted on the attempts as well? Not just
it depends on where it's coming from.
Oh, that would make sense.
Right.
Like if it's monitor like certain, okay.
Yeah, if it's in the cluster, you would get like, let's say an application was using some network tool to get at StackRox, right? That would come up as a violation of runtime in that application in the cluster. So that would be logged, right? If it was an external entity trying to get at the API, that would just depend on where it got blocked.
Right? Gotcha. All right. So we got an interesting question in chat here. Speaking of, Naveen asked, we saw one internal dependencies repo from image try to pull updates from public Git repo. Security captured that. Anyone experienced this? I feel like that is a very common use case.
Mm-hmm.
Yeah.
Like there's a lot of developers that are going to be like, hey, you need this file that's going to come from Git, or hey, you need this dependency, go pull it from Git, because they want a specific version of that dependency.
Mm-hmm.
Yeah.
I just
Like,
if you take a look at your Go mod file, right? Like it would just
right.
it's
Yeah.
like pulling from random Git repos sometimes.
Yeah. Like
You-
that's just kind of how Go works, right?
Mhm.
Like it pulls from github.blah.blah to pull in its dependencies.
Yeah, and you're going to have a bunch of different teams that don't have the same application, don't code the same way. So
Mhm.
maybe you have one application that has to run a init container or 3 init containers and has to pull information or secrets or
Right.
variables or whatever, right? What you can do is when that runtime process at initialization is known, well, you can flag it as a baseline to say, this is a normal
Mhm.
runtime process. This is for this team. This is expected. And then alert on anything that isn't those, right? So it's kind of one of those, it's that you need the flexibility. You can't just say any time that we're going and reaching out of the cluster for packages or dependencies, we want to
Mhm.
stop that, right? And
Yeah, no, your apps will break.
yeah, and what some dashboards, I should say, when you have network tools that don't actually use Kubernetes specific functionality, they might be in a dashboard and just say, hey, well, there's this weird network reach out. Okay, let's just block that IP address or that specific, right? So there's no real conversation between where the firewalls are, what's getting blocked, what isn't, and it's like a box around the cluster, not letting things in.
Mhm.
So there's just a different layer, and that's not saying that you can't use that tool and ACS, right? You can have the external firewall, and then you can have the network policies and the functionality in the cluster, right? It's also just how you communicate that information between teams.
Right. Collaboration is key is a theme
That's
for
right.
the day.
That's right.
For sure. Now, I think I have this default one that I kind of want to show. This is a old Docker demo. Very old. And there's no network policies. And I built this in GitHub and I pulled it using Argo CD, no security context, extremely, probably pretty insecure.
Yeah.
But let's go find it. Actually, I'll just hop over to Docker Hub and give you a quick run through of what's happening here. Actually, GitHub is probably the place to go. So I was thinking, I'm like, how do I sort of build this process where we can enforce the policies of ACS in the build process for developers, or maybe not enforce, but educate. Well, we're still letting them deploy, and then we can come back and say, hey, watch out. These are things that you need to fix before the next release. And you can consistently notify them over, let's say, the next 6 weeks. And if they don't fix them, then you say, hey, okay, well, I gave you time to fix these. And you're not communicating with us. So I was like, okay, well, let me pull an image and see what I can work up in GitHub Actions, even though GitHub Actions is not extremely intuitive.
Yeah.
So
can you zoom in a little bit?
Yeah,
please.
Good call.
Go
to just set everything to 250.
Yeah.
250. There we go. There it is.
So in this setup, it's basically just let me show this if I can zoom in on this one. It's this little Docker Labs getting started using mkdocs and basically initialize it, drop the file in, it's good to go. And what I did was took that and created a build YAML. This is a pretty big build YAML, but logging into Docker Hub, building the image, but then I'm doing a deployment YAML check, an image scan, and an image check after. And so the benefit of this is, let's say your developers already have their workflow set up and they already have their build process or their CI process for their build and they're pushing. Well, you can take rocksctl and go and install it at the end of these processes and then pull the security information close to them and display it to them without actually enforcing anything. And so then you can have that conversation about, these are some serious vulnerabilities that if you do not fix, you will not be able to push to production, right? These are the high ones. These are the ones that we care about. And you can set all this and build into the pipeline and you can test it without really interfering with that team, right? And if I go and show you, I had so many failures with this, but I finally got it to work. Scroll down. So the build is, well, if you use Docker, it's pretty straightforward. You have all of your layers. What is really important is we install rockctl and we reach out and make sure that we have the variables needed. And then what we do is we run a deployment check. So what this is going to do is it's going to reach out to the UI hub, pull the policies that are set up, and it's going to run them against the deployment YAML that we have. And so this one basically just fails right away because there's a bunch of stuff that isn't set up. And you can choose whether or not you want it to fail or not. I have this as continue on failure because we don't want to break the pipeline. We don't want to impede developers, right? We just want the information and we want it so that they can see it. Same thing with the image scan. I didn't format this all nice and pretty, unfortunately, but it has all the layers. And if we scroll through, we'll see that there are some serious CVSS scores with this.
Oh, 9.
Yeah. And
go.
so if I wanted to, I'd
10.
yeah, I would take, and really what I would probably do is I'd just take JQ, pipe it into a file, and then just, you can literally have it automatically sent as an email to a developer on the build, right? Or something like that, depending on what you use for your CI process. But it's just kind of a, hey, is everybody aware this build just, maybe it's not merged into the main branch, but this is a PR, this is a feature that we're adding, and there's some serious vulnerabilities with it. And it just makes everybody aware of what's going on. So there's the...
It's pretty cool that you can build it into the CI process because especially like if you're doing a feature branch, like you were mentioning, you can have it pass, right, for a feature branch, but then they have the information to where like, hey, by the way, when you merge this, we're not going to allow to merge until these are fixed, right? And so this is the whole Git workflows thing where it's like, okay, your CI told you that, here's the vulnerabilities you need to fix before we'll even allow you to merge this feature branch into the main branch. So this is that, which is pretty cool, right? It's all about information. It's all about fixing it earlier and often.
Yeah, and the reason that we designed it as rockctl, although I don't know if it's going to turn into ACSCTL, I kind of like rockctl, is so that because it's a binary, you can go and install it in a lot of different CI pipelines, and you don't need to worry about integrations. It's pretty much plug and go in a bunch of different setups. And because we wanted to be Kube native and be applicable to a lot of different use cases, it just made sense. There also is a difference between image scan and image check. Image scan just shows you CVSS, pulls information and compares it. Image check actually runs that against the policies that you've set up. So maybe there are certain CVSS and vulnerabilities you don't really care about. Well, let's work on image check policies that we only care about specific things. So for example, the Docker file here, the image has root. So this itself isn't that important because if you get into Kubernetes and you have your security context as drop all, it doesn't really matter.
Doesn't matter. Yeah, it won't run anyway. But
now it's like, okay, well, which layer matters? Because if the developer doesn't care, they're always just going to leave it as root. Okay, well, is that a practice that we want to stop with the developers? So again, like not every policy is important, and it's up to you to kind of figure out and have the conversation with the team to say, hey, maybe we should drop root because we're leaving your security context wide open. You can't have both, right?
Yeah.
And then obviously this fails, but continue on failure is...
Continue on failure.
Yeah. And what I did after that was I went to Argo CD and
Can you zoom in?
Oh, yeah.
This is going to be a theme.
Good call. And I got degraded. I don't know what happened.
Oh. You didn't pass the security check.
That's probably... But... Image pull back off. Oh, because 3.0? Maybe I messed up the config. This is 1.0. So rolled back.
Yeah.
Still got to work on the pipeline a little bit. But what I kind of wanted to show is if let's say you have that GitHub pipeline and it's continue on failure, and then Argo CD automatically goes and pulls it into, let's say, your test environment. If there are certain processes that you really care about or certain policies you want to enforce, well, then you just go into that CI process and you say, we're not going to continue on failure anymore, right? So part of the implementation is maybe it's, here are the policies you need to worry about. You have 3 months to come into compliance, and then we're going to stop allowing this continue on failure into your test environment, right? So there's there's like a give and a take, and you don't necessarily need to come in and enforce everything right away. And you can be a little flexible in how you set it up.
Yeah, you don't have to drop the hammer immediately. You just have to say the hammer will be dropped later. So,
yeah.
Right.
Thor's hammer will be inserted here.
Yeah.
Yeah, exactly. Yeah, and then the other thing that I did want to show too is there is integration obviously into pipelines. So we have an example of a ROX CTL pipeline, a pipeline run, where we cloned the workspace. We ran. Wait, is this the right one?
I think it's the other one.
Yeah. And we ran ROX-CTL against it. We found 3 alerts found based off of it. So as part of your pipeline, you can do a lot more honestly in this than you can in GitHub Actions. And I'd recommend, this is the next thing I want to work on, is just the build, the check mark. Okay, config, good. Are you ready to deploy? And then that's the manual stage at which you say yes. So you basically have parallel pipelines between configuration and image. You're violating them all, or you're violating them all. You're checking that you're checking them all against your policy standards, and then you can choose manually to deploy it or not. Anything else? Any other questions? And of course, from a management standpoint, you can look at your different clusters. All the system policies are here. You can reassess them. You can import specific ones. You can create new ones. Policy summary severities, and you can export them all through the API as well if you want to back up and go and redeploy somewhere else.
So SigStore is in the news again today for some reasons, and I'm curious, is there a policy that says like this image has to be signed?
That's in the roadmap. It's coming.
Cool.
So the image signatures and is in the roadmap. Binary authorization is already a thing. I think really only Google has it operationalized at this point.
Right. Okay, cool.
That I'm aware of. Otherwise, I mean, you can obviously do an OpenShift with SigStore as well. That's right. That's been an option for the last 1.5 years, I believe. So, yeah.
Cool.
But yes, the integration into ACS is on its way.
Nice.
Yeah. So that's like one of the things that were asked for a while is image signing. In terms of blocking things that aren't signed, right? And that's like a big thing, right? Like I want to know, like there's there's alerting, right? And like there's like kind of like kicking back sort of thing, but like there's also flat out like stopping even before it even touches my cluster, right?
Yeah.
So I know that's gonna be big, because I know a ton of people have been asking that for a while. So it's great that it's on the roadmap.
Mm-hmm. It still is only at the container level. So I would warn people that if that's the next bulletproof thing that you're worried about, just because the image that you built is the same image that's running in the cluster consistently doesn't necessarily mean
correct
that you're secure. You can build crappy images, obviously, and you can configure them improperly.
Yes, like you can sign an image that's a bad image. So like let's again, everything's a layer, right?
You're just
like
stopping any injection in that CI process, right?
Correct, right? Like it only matters if you've built it securely to begin with, right? So like I can sign my crappy image that's running, right? But that doesn't necessarily
mean it's good.
It doesn't mean it's good. It's just that it's a known crap.
It's a known image.
Yeah, it's a known bad image.
Yeah, known evil.
Known evil. Yeah, it's bad, but at least I know no one has injected anything in my bad image. So,
I also would probably get in trouble. I really should show this a lot more. So that the policy violations and CIS Docker standards and all this that it comes up, you can export all these as well. So when you have audits or things that pop up, it's very, very useful. If we look at some policy violations, you can see the categories here of the violation of the policies that they're violating. So for example, like Docker CIS and Docker CIS 4.1, and ensure that a user for the container has been created every time. So there was a couple that were running as root. right, that we saw where there was no user, that obviously violates the benchmarks. And so if you got audited for that standard, you'd fail. Here's how you rectify it. Make sure that all your Docker files aren't root. So we were talking about that as part of the CI process too. So that was it's like, hey, if we're going to pass this audit, we need to enforce this on our developers. So you have 2 months to get in line with that, right?
Can you say you can export it? So is that so I have two questions on that. So like one is that like a CSV or something, or is that just like a PDF?
Yeah, PDF. I believe you can do it in a CSV. Although maybe I'm missing something. This dashboard. I always believe you could export it in a CSV and a PDF.
Oh, okay, cool. And then is that like an open API? Like, can I automate? Like I always think like, is that an API I can hit and not just automate? Because all right, cool.
That's cool. Completely. The if you want to check, I don't want to go to the help docs right now, but the documentation's online and has all the API documentation as well that you can pull from. And so part of the policies that you create, so these system policies, is that you can export them, clone them, and edit them. So you can pull them into JSON format, have them all. And if you want to make changes to the policy, you don't even have to go into the UI. You can work on them separately and then just push them into through rockctl and implement the policy.
Nice. So you can essentially customize the policies for your not only just can you edit the ones there, or do you have to like clone and create the ones
you can edit them all in here. You can edit them directly. Obviously we recommend copying them instead of editing them. Just you can also
the built-in ones.
You can turn them off, right? Garbage them, disable policy, right? So that's pretty much all you and then take the defaults, edit them. The best thing about exporting is if you want to have two different UIs, so you have like a ton of different clusters, or maybe you have database specific clusters and then your stateless applications, and you like to separate them, whatever the use case is. It might be useful to basically pull the rules, and then if anything ever happens, because you've created all these very unique policies and you need to go and reconfigure it, you have them all in JSON. You can just go and, hey, take this, and then all the policies will pop back up. Sort of your redundancy. And rockctl does automatic. Well, rockctl, if you call it, will back up the database and back up the policies.
Nice.
So if you can automate that, or you can do it directly and export all the policies that you set up.
Nice.
So here, someone has a question. I don't know what it means, but I'll answer it here. It says, "Will Red Hat has future?" I think Red Hat does have a future. So
yeah,
I think the answer is yes.
It's been Chris, one of those days.
Hey, yeah, I was like, Chris, you look like you're over the day already.
It's been a weird week.
So it's been a weird week. Yeah. It like if folks, if you haven't heard, I've turned in my resignation. My last day is the 18th. So like, this is potentially my last stream.
This is your last voyage, right? Your last voyage on the Galaxy.
Thanks for making this day super weird for me. I appreciate it.
Yeah, exactly. So this is so I don't know if you wanted to show anything the last 8 minutes that we have here, the last few minutes here. I don't know if you want to show anything, or like if you want to talk about where people can learn more about ACS, or where they can find more information, more something to read, something to watch.
Sure. Yeah, OpenShift has the trial, and you can demo ACS for free, I believe, through the operator. Let me just go and pull it up. If you have OpenShift, the operator's up there. Feel free to test out advanced cluster security. If you have the time, honestly, it's worth it just to install it and see what's going on in your cluster. And
because there's nothing enforcing, right? Because when you install it, it's just information, which it doesn't hurt to try just to get information.
So when you install the secure cluster services, there are three components, which is the scanner, the collector, and there's the admission controller settings. So basically just listens, and you can have it so that there's a enforcement mechanism as well.
Nice.
There you go.
Yeah, but if I go over to StackRox, so for the documentation, everything's up online. If you want to check it out, you want to get started with RocksDTL, you can download it as well. It's all there. Backup, restoring, upgrading, operating, building into CI pipelines. Everything you need is in the docs. And there's a community site as well. StackRox is going to be or ACS is going to be open sourced in the future. I'm not sure exactly what the timeline is, but there's a community site for announcements as well, stackrocks.io, which I'm pretty happy about because the name gets to stay around.
Yeah,
That's
yeah,
cool.
there you go.
Yeah,
kinda cool.
yeah, pretty awesome.
And now it'll be the open source name, right? The upstream for ACS is StackRox. And also there's a Slack channel. So if you're on the CNCF Slack, there's a StackRox Slack channel there that you could. It looks like Waleed's on there, by the way. I'm looking at it right now, Chris. Waleed is there, so our biggest fan here.
I guarantee he's everywhere. Yeah.
I'm actually. I went to the StackRox Slack channel right now, and his name popped up. I'm like, hey, I know that guy. So there's another. If you're in the here, I'll copy and paste the link here in the chat. So CNCF Slack. So not only is StackRox on there, actually the Argo CD folks are on there. So if you have questions about Argo CD, all the engineers and all the community members are there as well. So and the GitOps working group is there. So it's not just StackRox.
Shocking. Yeah.
Yeah. Stacking Rocks is one of my favorite Zen games. By the way, so slight tangent. Like this has nothing to do with anything, right? So I play Assassin's Creed Valhalla. And there is a Stacking Rocks, I guess, side game, and it's like it is like the worst thing. It's like the most frustrating thing for me because my rocks keep falling.
I'm glad I stopped playing that game. Like
because
within the first couple missions,
well, like for like the OCD person in me, like I need to finish every little icon on the screen, and it's like
no, I hear you, right? Like I'm the same way. That's it's like,
and it's like
I
one
put
of
in
them's
the
like
game.
Stacking Rocks.
I started playing it, and I was like, "There's a lot of mini crap that I don't like in this game," and just completely set it aside.
Yeah, it's a terrible mini game. It's like but then like I'm sitting there for like 40 minutes.
Of course, because you're like, yeah, I got to
right?
cross off this one thing, and I'll be complete.
Yeah, and I'm sitting there. It's like the actual mission took me like 10 minutes, but like 40 minutes to stack the rocks. But anyways,
we'll put you on. We'll take your OCD and we'll put it against fixing all these CVEs.
Yes, that's right. Yeah, exactly. I need to go through and like knock off a lot of these. So that way.
If I put all these CVEs on a Assassin's Creed map, would you?
That's it. I would knock them out one at a time. Yes, exactly. I would. I definitely would. That'd be a way for me to. That's a good way for me to fix these. So there we go. Awesome. So is there any other questions here, guys? If not, I think we're almost out of time. We're at the hour.
A minute left. Yeah. Okay. Cool.
So if there's no any other questions, we can sign off here. Again, this is Chris Short's last GitOps Guide to the Galaxy. You probably heard this 1,000 times. You'll be sorely missed. This is your last voyage going toward the galaxy, but
I'm not going far. So
you're not going far. I'll see you next week at the at KubeCon. I guess the search is on for my co-captain. I guess for my next co-captain here at on the stream here. So
yeah, you got a candidate maybe right there.
That's right. I got candidate. Yeah, I'll maybe do like they're doing at Jeopardy, right? I'll test out a few. Make it a competition.
You should have a GitOps games. Little like
that's right. Yeah,
bring 3 people on, do a little trivia.
Who can build the best pipeline?
Yes, exactly. Right. Yeah, exactly. So who can? Maybe I'll have tryouts. Right. So this week's test can, and then we'll have GitOps.
Dress up in the Squid Games hood.
That's right. Yeah.
You've been eliminated.
You've been eliminated. Nope. And then we'll take off. So, anyways, thank you, Mike, for coming on, showing us StackRox. It was fun. You made me a fan of
right.
Saw it for the first time a couple weeks ago. So a lot of the times you get bogged down in your own little world and you can't really like once you start seeing other stuff that the community is doing, and stuff that Red Hat's doing, you're like, oh, that's really cool. That's a really cool piece of software, and that's one of the things that I thought of. So yeah, cool. So
Awesome.
yeah, there's no more questions in the chat, so I think we're good.
Yeah, no. You'll be back in 2 weeks with some more fun, right?
Yeah, I'll be back in 2 weeks. I guess I'll figure out the streaming thing. Hopefully by then, we'll see. You might get some Slack messages, Chris.
That's fine.
It's going to be a busy week next week.
It'll be busy. That's right. KubeCon, Chris. He'll be here, so I'll pull you aside, Chris, and say, show me how to do this.
That might actually be the best way.
That might be the best way. So we'll see.
All right, cool. Michael, we have a meeting tomorrow, so I'll see you then. But yeah, Christian, I'll catch you in LA on Saturday or whenever. Yeah,
whenever, we'll see it. Yeah.
All right, take it easy out and stay safe out there, folks. And yes, please find me if you're going to KubeCon. I definitely want to.
I'll be there too.
Meet you, and
pull me aside.
Christian and I will be around. Thanks, everybody. Take it easy. Stay safe out there.
Cheers.